Today we're going to go through some more review problems for the post-assessment that's going to be on Wednesday. And if you were absent today, which is Monday, there were only a few people that were absent. I'd like you to go to the problems at the very end of this video. I'll show you what we did in class today. So if you were in class today, which is most of you, you don't have to view the end of this video. You can stop. I'll show you where to stop. So anyways, here are your problems to go through and maybe look up if you forgot how to do them. I don't think I have to read them, but I will anyways. So using synthetic division, divide 6x cubed minus 4x squared plus 3x minus 2 by x minus 1. And express the polynomial as a product of a divisor and a quotient with a remainder. All this means is use this as one of the factors, and then whatever you get out of synthetic division as the other factor, and you'll have a remainder, and then just add or subtract that remainder at the end. So if you're not sure what this means, we'll talk about that in class tomorrow. The second question is about polar form of an equation. Here's one, r cosine of theta equals 8. Convert that to a rectangular equation. Here's another polar equation, r equals 2. Convert that to a rectangular equation. So these are polar forms. You can go look up polar forms if you forgot how to do those. Number 4, find the second derivative of this function, negative 7x cubed minus 3x squared plus 4x plus 1. Second derivative I'd like. And then number 5, this is the last question if you were here in class today. I'd like you to write the ordered pair, which is just in component form of the component form of the vector called AB. AB has point A at 7, 2, and point B at 2, negative 3. So I'd just like you to write component form of that. And those are the 5 questions for tonight. Maybe it'll take you a little bit of time to look them up, but hopefully not too much time. So, like I said, if you were in class today, you can shut the video off now and get working on those problems. And otherwise, if you were not in class today, you'll have to do all these problems plus the ones that we did in class today. And I'll just go through these with you. The first question is this, what we did in class today. I give you a turning point of a parabola. So the turning point is 2, negative 5. And then a second point on this parabola is negative 8, 15. I'd like to know what is the equation of that parabola. So my suggestion is for you to shut the video off right now and go look this up and see if you can remember how to write that quadratic equation. Or if you just like to listen to me, you can. So here's the vertex form. Remember, HK is the vertex, which is 2, negative 5. So substitute that in. Negative 8, 15 is the XY value. So when you substitute that in, you're going to solve it for A. And you go through a little bit of algebra, and then you come up with A equals 1/5. And so the equation of that quadratic equation is y equals 1/5 times x minus 2 squared minus 5. That's just vertex form, and you can leave it like that. Second problem is I gave some parametric equations that you need to convert into rectangular form. So here's the first one. X equals 4 plus 2t and y equals negative 5 plus t. So converting those parametric equations into rectangular form, you can shut the video off if you'd like to right now. Go look it up. Or if you just like to listen to me, you can do that too. So what you need to do is to solve this for t. So if you solve this for t, you subtract 4 and divide by 2, and you get x minus 4 over 2 is equal to t. And then you substitute x minus 4 over 2 in for that t, and you get y equals negative 5 plus t, and the t would be this. So I just divided this into 2 fractions, x over 2 minus 4 over 2. So this becomes negative 5 plus 1/2 x minus 4 over 2, which is 2. So you can combine those two like terms, negative 5 and negative 2, into negative 7. So y equals 1/2 x minus 7 would be that rectangular form. The next problem is converting trig equations into parametric form. So here's the next set of parametric equations. X equals 3 cosine of t, y equals negative 5 sine of t. And so if you could shut the video off now and look that up, that would be to your advantage to look it up yourself. Or if you want to listen to me, you can solve this for cosine of t by dividing both sides by 3. Solve this one for sine of t, divide both sides by -5, and you get x over 3 is cosine of t. Y over -5 is the sine of t. And if you remember, sine squared plus cosine squared equals 1. So you're just going to substitute those two, square them, and make them equal to 1. So x over 3 squared plus y over -5 squared is equal to 1. And then what you come up with is x squared over 9 plus y squared over 25 equals 1. This is an ellipse, by the way. Not that you have to know it or anything, but it's an ellipse. If both of these values were the same in the denominator, it would be a circle. And if it were a circle, you just multiply through by whatever that denominator is on both sides. The other question we did today was we did a couple questions on limits. So here's a graph. It's just a weird graph, but it has an open circle here at -3, 2. And I wanted to know what is the limit of this function with an open circle here as x approaches -3. So if you want to go and look up your limits, remember this is an open circle, your limit definition, that would be great. Shut the video off and go look it up. Sorry. So in this particular question, what is the limit of this function as x approaches -3? Well, the question is really asking, what does the y value approach when the x value approaches -3? Well, if you're approaching -3 from the left, the y value is 2. If you're approaching the x value of -3 from the right, the y value is still equal to -2. So the limit of this function as x is getting close to -3, and there's no plus or minus here, so it's from both directions, the limit is equal to 2 because that's the y value. Even though there's an open circle here, it's a discontinuous graph, this limit is still equal to 2 because that's the y value. Now on the other hand, if you have a function that has an asymptote here at x equals -3, what's the limit of this function as you're getting close to -3? Well, coming in from the left, this limit is infinity. So if you had a little plus sign here, or I'm sorry, a little minus sign here, -3 from the left, it would be positive infinity. If you had a plus sign here, it would be getting close to -3 from the right-hand side, and that would be negative infinity. So because the left limit is different than the right-hand limit, then the limit for this function, if there's nothing up here in this upper corner, the limit does not exist because they're different, unlike this, which were the same numbers. This one does not exist. And then here's another function. This function is actually the absolute value of x over x. And so if you're coming in from the right-hand side, the limit of this function as x approaches 0, and this little minus says coming in from the left. Minus means come in from the left. This limit is -1 because the y value is approaching -1 as x comes into 0 from the left. If you had to find out what the limit is as x approaches 0 from the right-hand side, this limit is +1. But if you want to find the limit as x approaches 0 and you don't have a plus or minus here, it does not exist because these two y values are different when you're approaching 0 from the right and from the left. These two are not equal to each other, so the overall limit does not exist. And then the last question that we did in class today was this. Let's say we have a linear function, f of x, and this linear function has an x-intercept at 7, and it has a y-intercept at -5. Sorry for this dark, this bled through from the other side. So the x-intercept is 7, the y-intercept is -5. What is the equation of the derivative of f of x with this information? Well, if you'd like to shut the video off now and try to figure that out, it would probably be best so you can go through these mental exercises yourself. Or if you'd like to just listen to me, that's fine too. You won't learn as much though. So first of all, what I would do would be I would draw the linear graph with the x-intercept of 7 and the y-intercept of -5. So there's your linear function. And then I would come up with an equation for this. Well, since it's linear, you just have to find the slope by rise over run. And rise over run is 5 over 7. The y-intercept is -5. So the equation of this function I figured out was y equals 5/7 x minus 5. Well, what's the equation of the derivative? Well, all you have to do is take the derivative of this function, and the derivative of y equals 5/7 x minus 5 is dy dx, or f prime of x, or y prime, whatever you want to call it, it's all the same. Dy dx is equal to 5/7 because it's just the slope. Oh, there is one more problem, sorry. I have to draw it myself. And here's your last problem of the day. Really, truly. Let's say you have a nice little parabola. This is a quadratic function. And I want you to draw f prime of x right over the top of, or not over the top, but on the same set of axes as this. What would you do if I asked you to draw f prime? So if you wanted to just copy this down and try to figure out what f prime of x is, that would be wonderful. Or if you want to just watch me do it, you can do that too. So the important part is this local min right here. The local min has a derivative that's on the x-axis. So here's the local min. Local min directly above is the x-intercept. Well, this slope is negative. So because the slope is negative, the derivative must be negative. It must be underneath. And from here on up, the slope is positive. So the derivative graph must be positive. So this red would be f prime of x. And that's it. Just figure out the local mins or maxes and put the x-intercepts, and then figure out if it's the slope is negative or the slope is positive. And that's it. So see you tomorrow.